Hello everyone. In continuation to our non-parametric test, next we will see how do we use Kolmogorov-Smirnov test for testing the goodness of fit of a particular data. See here the question is, the following is a random sample of size 20. The test whether the sample can be considered as a sample from a N01 distribution, means from a standard normal distribution. Data given here 2.24, negative 0.4, like that till 0.101. Primarily, we need to find both the empirical cumulative density function value and the theoretical cumulative density function value based on standard normal. So let us create one table here having, let's say, 5 columns. And I think here there are 20 values. So we'll create 21 rows. 21 rows and 5 columns. So the first column will be serial number. Then the value what is given, that we will be organizing it in ascending order. Then empirical value, empirical CDF, which we can call it as we'll use this notation. Capital F, suffix N within brackets X. Then we will have theoretical CDF, which is denoted by phi of X. Here we will have the modulus of these differences. This minus this. So we have 20 observations. We'll write the values in ascending order. Means among this, the least number we need to write it first. So here it is, what do you call, 1.152 negative. That is the least. Then the next least is negative 1.053. Then the next least is negative 0.87. Then the next least is negative 0.625. Then the next is negative 0.4, then the next least is negative 0.34, negative 0.164, then next is negative 0.128, then the next least is negative 0.041, then I think all negative numbers are considered. Next least is 0.101, then 0.27, then 0.323. Yeah. Then 0.361. I missed this 1 minute. Let me shift this because I missed one number. This one I missed it. 0.123. Come here. Value. Yeah. Okay. 0.682. Next list is 0.98. Then next 1.187. Then 1.405. Then 2.24. Two 2.323. That is the highest value. Now, we have to calculate the empirical CDF values. This is done by, for each data point, the empirical CDF value is I divided by N, where I is the position. in the sorted list, and n is nothing but 20. So in which case here first one will be your 1 divided by 20. That will give us 0.050. Similarly, 2 divided by 20, 0.100. Next, 3 divided by 20, 0.150. Next will be 0.200, 0.250, 0.300, 0.350, 0.400, 0.450, 0.500, 0.550, 0.600, 0.650, 0.700, 0.750, then 0.800, 0.850, 0.900, 0.950. Last will be 1.000, 20 by 20. So that will be our empirical CDF values. Next is theoretical CDF. For example, when we say value is this thing, theoretical CDF is nothing but probability of negative infinity less than z less than the given value. For example, first one, it is probability of negative infinity, serial number 1. It will be probability less than z less than 1.152 negative. So that we will get it from the tables, standard normal tables from negative infinity. Let us see what is that table shows. 1.15. This is negative 1.1. This is 0, column 0, column 1, 2, 3, 4, 5. Means we get 0.125. Straight away we can write that. 0.125. Similarly, for the next one, we will check the same table up to negative 0.53. Sorry, negative 1.053. Negative 1.05. 1, 2, 3, 4, 5, 6. That is this one. 0.146 that we will consider. Similarly, for the next one, it will be 0.92192. Then 0.266, 0.345, then 0.367, then 0.435, next 0.449, next 0.451, then 0.484. Then we get a positive value. For positive value, how do we see? 0.101. This means, let me use other table. This table is also standard number tables, but it is from 0 to Z value. Here we are interested in 0.101, 0.10, which is giving you 0.398. 0.398. We need to add what you call 0.5. So if I add 0.5, why 0.5? Because negative infinity to 0 is area is 0.5. That needs to be added. So it works out to 0.54. Like that we have to do. Means for positive values, we'll be referring 0 to Z tables and then add 0.5 to that value. So here we will get 0.54. Next, for 0.27, it will be 0.606. Then for serial number 13, it is 0.323. It will be 0.627. 0.361, it is 0.641. Then for 0.682, it will be 0.752. Then for 0.98, it will be 0.882. Then for 1.187, it is, sorry, this is 0.887, 882, and this one is 0.836. Then for 1.405, it is 0.920. Then for 2.24, it is 0.987. Then for 2.323, it is 0.990. Here we are going to calculate the difference of this f of fnx and psi of x, these two. So first one, the difference, and then modulus of the difference. If I subtract 0.05 minus 0.125, we get negative 0.075. Since there is a modulus, we will be writing 0.075. Next one will be 0.046. Next one will be 0.042. Then 0.066. Then 0.095. 0.067. Then 0.085. 0.04. 0.001. That is 9th serial number. Then 0.016. Then the difference 0.010. Then 0.006. Then 0.023. 13th value. Next 0.059. Next will be 0.002. Next will be 0.0036. Then, sorry, single zero. Next will be 0.032. Next 0.020. Next 0.037. The last 0.010. So we will have a total, not total, actually we have to find the max value. We'll find D. D is the calculated value here, is max of this. Maximum of this difference. If we look into the maximum difference, we get 0.095. Then the critical value for to determine the critical value for smaller sample sizes, like n is equal to 20, we use the exact critical values from the Kolmogorov-Smirnov table. Kolmogorov-Smirnov table. So we will bring that table now. So this is the table. N is 20. So we have to refer to this 20. And level of significance is 0.05. That works out to 0.294. That is the table value or the critical value. So at the level of significance of 0.05 and n is equal to 20, the correct or the critical value is 0.294. Now, inference. Since the calculated value, that is D, which is equal to 0.094, 0.095, no? 0.095. 0.095 is lesser than the critical value, which is 0.294. We fail to reject the null hypothesis. So I didn't write the hypothesis. Hypothesis should have been written. Say H naught is the sample came from a N01 distribution. And then H1, I'll copy this, modify. Actually, we should have written in the beginning itself the hypothesis. The sample do not come from. This will be the null and alternative hypothesis. So here we can conclude in that inference as we fail to reject the null hypothesis. So, hence, there is insufficient evidence to reject the null hypothesis, and hence we accept it. So that will be the solution for this question.